Okay, the next work that we want to look at is the work of a weight. Now guys, I just want to remind you that everything always comes from this equation. The work of a weight is equal to the integral of f dr. All you need to do is find out how is this force expressed and how is this displacement expressed. Or its work is equal to the integral of f cos theta ds. Right, these two are really where we begin solving all these work problems. Okay, so from these you can solve any work problem. Okay, so now we want to look at the work of a weight. So we start here. The work is equal to the integral of f dr. Now what is, okay, sorry, let me just backtrack. Let's consider a particle that's moving from S1 to S2. Okay? Just moving from S1 to S2. And what is the, if we're considering the work of a weight, then the weight is acting down. Okay? So, if we look at this expression and we want to elaborate on this, what is the force? The force is weight, W, acting down, minus J. Okay? So that's our weight. This is in vector form now. And we are dotting it with the differential displacement. So the differential displacement is dr. So if we're looking at dr here, it is the differential displacement in the x, the y, and the z direction. Okay? Now if we dot each of these, if we dot this term with this first term, we're going to get a j dot I. And what is j dot I? It's 0, right? Because it's the dot product. You're looking at the cos of the angle between them, which is 90, which is 0. What about this term dot this term? It's going to be j dot j, so we're going to keep it so it's minus w times dy, and that's what we have there. And then if we dot this third term, we're going to have a j dot k, which is also 0. So we end up with minus w times dy. That's what we have. Okay? And we are just left with, instead of looking in the x direction and the z direction, we are left with just the y direction. So we're left, the integral becomes between y1 and y2. Okay, then we have minus w dy. It is equal to this. Minus w, final vertical position, minus initial vertical position. Okay? And this is the expression for the work of a weight. It is minus w times delta y, where delta y is final minus initial. Final minus initial. Okay, so that's all the maths, but so a few things that I'd like you to take note of. Okay, when we are looking at the work of a weight, we are simply looking at the weight times the vertical displacement. What do I mean by that? So now you have a box here on the floor, and you lift it up and put it on a shelf. So there's a shelf, you lift it up and you put it on a shelf there. Okay, now ignore the work that you do by picking it up. But if you just consider the work of the weight's acting down, and it moves from there to there. So what would the work of the weight be? It would be minus W times only this vertical change, right? Delta Y. It's not going to be anything in that direction, and it's not going to be that distance. It's only going to be the vertical distance, because work is equal to the dot product of the force and the displacement. It is only the component of the displacement that's in the same direction, along the same direction, yes, the same direction as the weight that we consider. Okay? So now, so that's the first thing. The second thing is if I lift up this box from there to there, what is the work of the weight? Is it positive or negative or zero? It would be negative. You can see that even without calculating anything. First of all, what is the direction of the weight vector? It's down. And what is the direction of the displacement vector? It's up. So whenever you have the force and the displacement vectors in opposing directions, you've got negative work. However, if I took that box and I picked it up and I placed it down on the floor, then the weight vector, the force vector, and the displacement vector would be in the same direction. And you can see that it'll work out like that. If this is a positive value, if delta y is a positive value, meaning that y2 is larger than y1, then this is positive, which means that the work of the weight will be negative, which makes sense. I'm lifting it up to a higher position, my y2 is larger than y1, and so my vectors will be in the opposite direction. So this will be plus, that will be negative, I get a negative weight. However, if I bring this down, my y2 will be less than y1, which means this will be negative, that'll be negative, and I get a positive, which means I have positive work. It's acting in the same direction. Okay? Good. In the next video, we'll look at the work of the spring force.